Alright, the next chapter is electrochemistry. This is chapter 19 in your book, where we are going to take a look at redox reactions. So, the first half, I'm going to spend some time on concepts that you may or may not remember from Gen Chem 1, depending on when you took it, where you took it, who taught you. So, since I have more than one variable, I'm just going to go over that particular component so the entire class is on the same page. And then we are going to start applying that towards the concept of batteries, galvanic reactions, cells in general, and take it from there. Okay, so first things first, what is a redox reaction? Redox reactions are those reactions which involve a reduction reaction and an oxidation reaction. Realize that a reduction reaction cannot occur on its own. Likewise, an oxidation reaction cannot occur on its own as well. So the two always occur in conjunction. What that means is that if there is a species that undergoes reduction, there must be a species that undergoes oxidation at the same time within the same system. That means the oxidation and reduction must occur together. They cannot exist alone. So over here I'm showing you a reaction. I'm going to write this properly because the formatting for some reason doesn't quite work. So my reaction is Fe0 plus Cu2 plus gives you Cu0 and Fe2 plus. In this process, hopefully you can see that Cu2 plus has gained reactions, gained electrons in going from Cu2 plus to Cu0. Likewise, Fe has lost electrons, and so your two half reactions, as they're called, are going to be Cu2 plus plus 2 electrons, giving you Cu, and Fe giving you Fe2 plus and 2 electrons. Loss of electron is oxidation, gain of electron is reduction. That is why Leo, the lion, says grr. So loss of electron again is oxidation, gain of electron is reduction, and that is the reason why we would say that in this particular reaction Cu2 plus is gaining the 2 electrons and becoming copper. Fe is losing the 2 electrons and becoming Fe2 plus. So another way to look at it is that if your oxidation state increases or oxidation number increases, it's oxidation. So increase in oxidation number, that's oxidation. Decrease in oxidation number is reduction, or reduction in oxidation number. Notice it was plus 2, it became 0, so that's a decrease, and I call that a reduction reaction. Fe is going from 0 to plus 2, so it must be an oxidation reaction. Recall from Gen Chem 1 that the copper 2 plus is essentially a blue colored solution, and copper metal is a red precipitate. So as the reaction takes place, you will see a discharge in the color of blue and the appearance of a red precipitate in the system. Now in the process, hopefully you can see that Cu2 plus has gained electrons, it's reduced, and that is why we call it an oxidizing agent. Likewise, Fe is the species that lost electrons, so it behaves more like a metal, and we are going to call it a reducing agent. So the species that itself undergoes reduction but oxidizes other material is what is called as oxidizing agent. A species which itself undergoes oxidation reduces other species is what is called as the reducing agent. Usually, you should know this information, usually metals, they tend to go through oxidation. And so you would find good reducing agents on the left side of the periodic table. On the other hand, nonmetals tend to gain electrons better, and so they would behave as oxidizing agents. So nonmetals, or elements that are more on the right side of the periodic table, are going to behave better as the oxidizing agent. And hopefully you can even see oxygen is going to oxidize other material, or chlorine. The reason why you put that to cleanse water is because it basically oxidizes the DNA of the bacteria and kills the bacteria that way. So you will find more nonmetals in the oxidizing agent list, whereas you'll find more metals like sodium or potassium in the reducing agent list. The question is, which is the reduction half reaction? Notice reduction means that you're supposed to gain electrons. And so the first three are showing loss of electron. It's the last one which shows gain of electron. That's my reduction half reaction. Alright. Another question is, for each of the following, identify which species is reducing agent and which one is oxidizing agent. And you should know this stuff. You can get that for 1 point. You would be given an equation and you'll have to, pick a choice based on what is provided. So the question is, you have to identify the reducing agent and the oxidizing agent. Now there are two ways to do that. The first one is that you always look for where the oxidation is, where the reduction is, and you go with that. And another way to do that is that you basically look for what the metal is and what the non-metal is. So for example, all metals are good reducing agents. That means Ca to Ca2 plus, that's a loss of electron. That means this is your oxidation. H plus to H2, that's plus 1 to 0. And that will be your reduction. What undergoes reduction itself is an oxidizing agent. What undergoes oxidation itself is a reducing agent. And we're going to apply the same thing again. We have Fe2 plus and chlorine. Fe2 plus becomes Fe3 plus. That's a loss of electron, so that's oxidation. Metals undergo loss of electron, so that's reducing agent. Chlorine to Cl negative, that's going to be a reduction, and hence it will be the oxidizing agent. The last one is tin oxide with carbon. So notice that tin is going from a combined form to metallic tin. So this is 0 here, and this was plus 4. So loss of oxygen is reduction. Loss of oxygen is reduction. Gain of oxygen is oxidation. Likewise, a loss of hydrogen is oxidation, and gain of hydrogen is reduction. Gain of hydrogen atoms is reduction. You will use these last two that I said in terms of definition in biochemistry or any biology class. That's how they do that. So you should know all four essentially. You can also determine the charge, which is what I did to determine essentially what's reduction, what's oxidation. So whichever route you want to go, the answer is going to be the same. Anyway, you're going from plus 4 to 0, or you can call it loss of oxygen. So this is a reduction half cycle. That means this is going to be your oxidizing agent. On the other hand, carbon is undergoing oxidation because it's gaining oxygen, so that is your oxidation, and that means that this must be your reducing agent. So realize the rule that I gave you earlier about the metals being reducing agents and non-metals being oxidizing agents was for metal and non-metal as elements, but realize here it's in the combined form, so that rule cannot just be taken, cannot just be followed blindly. Basically, you still need to work out what's reduction, what's oxidation to work out your overall answer, but it works 97% of the time. Okay, let's go forward. Just a general recap of oxidation numbers. The charges that we are providing are really the oxidation numbers, depending on whether it's monoatomic or diatomic or what, whether it's in a combined form or in the elemental form, you can assign a charge that goes with it. So for example, any atom in its elemental state is going to get a 0 charge. That means that whether if you have a bromine or a hydrogen or a sulfur in its elemental form, we are going to assign it a value of 0. So all diatomics, for example, H2Br2, O2F2. So remember the no fear for ice, cold beer, and hot peppers. That's N2O2, F2, iodine, I2, Cl2, Br2, and H2. These are all the diatomics. So realize that diatomics are going to be given a charge of 0. We are not saying that each of them is going to share that charge. We are just going to say that H2 is going to get a charge of 0. If you have a monoatomic ion, so for example, if you have Na plus or Cl minus, then Na plus will get a positive 1 charge, Cl minus is going to get a negative 1. So if you had Na in NaCl, you would say this is group 1, that's going to be plus 1, Cl is going to be negative 1. So realize the representative metals, which is group 1, group 2, and aluminum, they're going to be considered my friends, and so you can simply use the charge on the group number as the charge on those elements, because they are your friends, they're trustworthy, and they're going to get the charge straight away from the group number. The problem lies in case you have transition metals, or if you have polyatomic ions. In that case, you have to follow certain rules to figure out what the charge is going to be. So for example, if you have let's say something like SO4, let's call it H2SO4. Now, the certain rules, hydrogen is always plus 1. The only time that it is negative 1 is if it is bound to group 1 metal, group 2 metal, or aluminum. So since lithium is always plus 1, hydrogen will have to be minus 1. Since calcium is plus 2, hydrogen will have to be negative 1 here as well, because you would say plus 2 plus 2x is equal to 0, or x is equal to negative 1. And likewise, in case of AlH3 also, you're going to give it a negative 1, minus 1 value. Other than that, it always is a plus 1. Oxygen, on the other hand, usually is minus 2. The only time that it is minus 1 is if it is present in a peroxide. And halogens usually get negative 1 other than when they are bonded to oxygen. In that event, they basically start getting a positive value. So keeping those rules in mind, let's plug those and figure out the charge on sulfur. So that is my unknown. So since hydrogen has plus 1, you have 2 of those, plus x plus 4 times negative 2. There is no charge on the molecule as such, so you say 2 plus x minus 8 is equal to 0, or x is equal to plus 6, and that is your charge on the sulfur. That's what we have here. Let's go forward. Likewise, in case of ClO4 with a negative charge, if I had to determine the charge on chlorine, I would say 4 times minus 2 is -1, and so x is plus 7. What is the physical meaning of this plus 7? This basically goes back to, or can be correlated to, the structure. So that's the structure of HClO4, and notice on the chlorine I have 7 bonds. So that's the physical meaning of um, this charge, of this contribution towards the charge. Alright, the question is that you have to assign oxidation numbers to each atom in the following substances. So realize some of these are polyatomic, some of these are binary. So we'll take one at a time. Let's consider CDS. And so since sulfur is group 6, that's going to be -2. That means cadmium will have to be +2. AlH3, aluminum is +3, so you would say +3 plus 3x is equal to 0, or x is equal to -3/3, which is 1. Dry Lab 5 will have lots of questions based off of this, so make sure you understand how to go about this. Sodium dichromate. Sodium is trustworthy, +1, so +1 times 2 plus 2x plus 7 times -2 is 0, or 2x is equal to 12, or x is equal to 6. Tin tetrachloride. So Cl is -1, and that would mean tin is, the charge is +4. You can get that from the binary charge itself. V2O3, hopefully you can see vanadium is +3 for the charge, oxygen is -2, and so those will be the formal charges as well. Let's see, MnO4 minus, so Mn is the unknown, +4 times -2 is equal to -1, or x is equal to +7. Let's consider vanadium and VOCl3. So that's x minus 2 plus 3 times -1 is equal to 0, or x is equal to +5. So this is -2, this is -1, and that's 5. Fe2O3, this is +3, oxygen is -2. Sulfate together is 2 negative, that means iron is +2, and we calculated sulfate earlier to be +6, oxygen is -2. HNO3, let's do that one. HNO3, so hydrogen is 1, nitrogen is what I'm seeking. 3 times -2 is 0, so x is equal to, x minus 5 is equal to 0, or x is equal to +5. And the last one is H2PO4 with a negative charge, so 2 times 1 plus x for phosphorus plus 4 times -2 is a -1 charge. So 2 plus x minus 8 is equal to -1, or x minus 6 is -1, or x is equal to 5. So those are my charges. Hopefully you were able to follow the math as we went along. All you got to do is use the rules, and the one that you don't know, assume that to be x, and then solve for that x, forming a linear equation for each of them. For binary compounds, it's pretty straightforward. Whatever is your formula, that itself tells you the charge on the cation and the anion, and those are the formal, or the oxidation numbers as well. Okay, the question is, what is the oxidation number of arsenic in AsO4 negative? AsO4 negative. And so you're going to follow the same rule. X plus 4 times negative 2 is negative 3, or x minus 8 is equal to minus 3, or x is equal to 5.